Hi, welcome to Cracku. In this video, we'll be looking at one of the most integral parts of geometry, which is solids and its volumes. Right? These questions might be a bit calculative intensive, but they're questions that everyone can do and can definitely get marks. So we'll look at the formulas one by one, and then we'll be solving questions based on those formulas. So starting off with the most basic formula. So cube, everyone knows what it is. It is a solid figure where all six sides are squares and the volume is nothing but a cube, where a is the length of one of the sides. And a cuboid is an extension of a rectangle with another dimension which is called height. Right, similar to a cube where it has six faces. A cuboid also has six faces. It's just that there are three dimensions: length, breadth and height, where in the cube all three dimensions of the same value, which is a. Right, so volume of a cube is a cube, volume of a cuboid is lbh. Now coming to some of the more interesting shapes, a right circular cylinder, the volume of that is pi r square h. So right circular cylinder is basically it's a cylinder, right? It's got parallel circles on either end, right? And it's got a lateral surface, right? The radius of the circle on the base is r, and this is h, right? The total volume will be pi r square h. Right? Similar to that is a right circular cone, right? Where a cone is a converging shape with the base of a circle with a radius r, right? This is h. Right, a cone also has a lateral surface length of L, which we'll be discussing in the next video with surface area. But for now, the length is h and the radius of the base circle is r, and the volume would be 1 by 3 pi r square h. Right. Now, a frustum is very interesting because it's nothing but a cone which is sliced off here or anywhere. So basically a cone, where we can draw a cone here, and then it's sliced off at a particular length. So there will be two circular bases, one circular base on the top, right, and one circular base on the bottom. The bottom one will remain obviously R, or we'll call it R1, and the top one, a new circular base which is formed, also will have a radius, right, that will be called R2. So so a frustum is basically a shape that looks like this, right, with a circular base on top, with a circular base on the bottom. Obviously the circular bases are not equal, but they are parallel, and it's got a lateral length, right? So this is the small radius and this is the bigger radius, right? And the formula to calculate the volume of this would be 1 by 3 pi h. H is the height after it's been cut off. H r1 square plus r2 square plus r1 into r2. So the dimension remains the same, even though it's a longer term. It's still squared of the radius into the height, right? A sphere is 4 by 3 pi r cube, right? Which is, a sphere is a spherical object where the radius r, right? So it's basically a ball. A ball is a sphere. So the volume would be 4 by 3 pi r cube, right? A hemisphere is half a sphere, right? It's got a circular base on the bottom, and then there's a half a ball structure on top. So volume would be naturally half of this, which would be 2 by 3 pi r cube. A hollow hemisphere, even though it's not a solid, the volume remains the same. You can still fill water into the hollow hemisphere or anything. The volume still remains the same. It's 2 by 3 pi r cube. Right, a tetrahedron is basically a solid with all four sides as triangles, right? So basically a tetrahedron would be something like a triangle here, right, and then there is a point here, right, and all of that is connected. So it's basically 1 2 3 4 4 sides of triangles, and the volume, and each side, if it's a equilateral tetrahedron where each side is a, the volume of it would be a cubed by 6 root 2. They tend to be equilateral where all the sides are equal, because all the points are equidistant to each point. So a tetrahedron is basically formed when there are 4 points in a plane, right? A three-dimensional plane, there are 4 points where each point is equidistant to each other, right? So when you join all 4 points to each other, it becomes a tetrahedron. A prism is slightly different. right? Because there are multiple kinds of prism. A prism is basically a solid shape with two identical parallel sides, right? And the rest of the sides are lateral cross sections, which a prism can be a triangular prism, it can be a rectangular prism, a square prism, or anything. Let's take triangular prism. Since we just did tetrahedron, we can see the differences, right? A prism is a triangle here, right? We have another triangle here, right? And we join all those sides, right? We get three lateral sides. We get a rectangular base, we get two rectangular sides that are converging on each other, right? But there are two triangles which are equal and parallel to each other with lateral cross sections, and this can be done using with even a cube, right, which would basically be a cuboid, right? But it's still a prism. Prism is basically two shapes that are parallel to each other, two equal shapes that are parallel to each other with lateral cross sections connecting them, and the area is basically base into height. So the area of a rectangular prism would be the area of the base of the triangle and this height, right? So if this is an equilateral triangle, the area would be root 3 by 4, and if this is a square, and if this is the height h, this would be the volume of the prism. A pyramid is very similar, right? It's got a square base, right, and it's got triangles on either on all sides, right? Just joining. Apologies for my visual diagrams, but yes, basically a square base with four triangles converging on each other, the area of which would be 1 by 3 into area of the base, which is square, into the height, not lateral height but straight perpendicular to the base. That's the height. Let's solve some questions. 4 points are arranged in a space such that distance between any 2 points is 6 meters, right? Find the volume of the solid formed by joining all the 4 points. So we just discussed this, how a tetrahedron is formed, right? It's basically when in a three-dimensional plane, when there are 4 equidistant points, all of them connected to each other will form a tetrahedron, right? So let's draw it. So there are 4 points all equidistant from each other, right? I can't draw in, this is not a three-dimensional space for me to draw, but a fair amount of imagination, right? This can be the base, and let's say this is connected here, this is connected here, and this is also connected here, right? So we get a shape of 4 triangles, right, basically, right? So there's one triangle here, one triangle here, one triangle here, and one triangle here. So all the 4 triangles are connected to each other, all of them are equidistant. That means the length of each side is also 6 meters, because it's given that all points, distance between any 2 points is 6 meters. So 6 meters is the distance, right? Recalling the formula of a tetrahedron, we can write tetrahedron formula is equal to a cube by 6 root 2. Right, so a here is 6 meters, since it's given that it's all equidistant. So 6 cube, which is 216 divided by 6 root 2. So 6, this would be 36 by root 2, right? And this would be 18 root 2. Let's go to the next question. A large cylindrical bucket of radius 60 centimeters and height 1.2 meters. So bucket 1, right, radius would be 60 centimeters, height is 1.2 meters or 120 centimeters, filled up to 70%, is to be filled up to 70%. We need to fill it up to 70%. For this purpose, a smaller cylindrical bucket, so there's a second bucket of radius 20 centimeters and height as 40 centimeters, right? And there is 20% spillage. That means it can carry, let's say on average, it can carry only about 80% of its volume, because 20% would be spilled. So there's an 80% carrying of the volume. How many small buckets are required for filling the large bucket up to 70%, right? So the volume that is to be filled is the volume of the cylinder into 70% of that volume. So the volume of the cylinder will be pi r square into h, right, divided by into 70%. right? The volume of this bucket would be pi r square into h. And now since 20% spillage, so on average you'll be carrying about 80% of its volume, so 0.8. So right, this is the volume 1 and this is the second volume. Now we need to find out how many of these volumes is required to fill this volume. So which is basically V1 divided by V2. So doing that, right, so simplifying this, cancelling out pi, 20 and 60, right, so this would be, so sorry, I'm so sorry, this is square, so this would be 3, so 3 square would be 9 here, so 9, right, and this into this would be 3 again, so 9 into 3 into 7 divided by 8, right, so it would be 21 into 9 by 8, which is equal to 189 by 8. Right, solving this, you will get 23.625. Right, so the answer is 24. Okay, the next question. Find the slant height of the frustum of the volume. Biggest radius and smallest radius are 350 pi, 10 centimeters, and 5 centimeters. So we've given the bigger radius as 10 centimeters. Smaller radius as 5 centimeters, right, and the volume as 350 pi. So recalling the formula for volume of the frustum, it would be 1 by 3 pi into r1 square, which is 100, r2 square, which is 25, plus r1 into r2, which is 50. This is equal to 350 pi. Cancelling out pi on either side, this would be 175 by 3. And obviously this is into height, my bad. So volume of the frustum is 1 by 3 into pi into r1 square plus r2 square plus r1 into r2 into the height of the frustum. So if the frustum is like this, where this is r2 and this is r1 and this is the height, so the volume would be 1 by 3 pi r1 square plus r2 square plus r1 r2 into h. So into h, so 175 by 3 into h is equal to 350. So this 2, so h we will get as 6 centimeters. So now we need to find the lateral length of the frustum here. So we can do that by, let's draw. So basically when you look at a two-dimensional end of a frustum, it's basically a isosceles trapezium, right? So this will be 5 centimeters because the radius of the smaller circle is given, right? And this would be 10 centimeters. The height is 6, right? So this is the midpoint, right? So if this length is 5 meters, right, which is equal to this length must be 10 minus 5. So 10 minus 5 is equal to 5. So this length is 5 and this length is also 5 because 10 minus 5 is equal to 5. So this, because this upper radius, the smaller radius is equal to 5. So parallel to this is equal to 5 and this is the remaining of the, after subtracting from the larger radius. So and the height is 6 meters, which we found out here. So using Pythagoras theorem, we can basically find the hypotenuse, which is 36 plus 25. Right, so if you, it's basically 6 square plus 5 square, right, which we will get 36 into 25 and this will be root 61. Now there is a right angle triangle such that AB is equal to 3, BC is equal to 4, CA is equal to 5. So the most basic right angle triangle. Now the triangle is rotated about each hypotenuse. So there's a typo in this question. So it's rotated about the hypotenuse. What is the volume occupied? So let's draw the right angle triangle first. Right, let's make this 3, let's make this 4, and obviously this would be 5. Right, so we need, so this particular shape is rotated about its hypotenuse like this, right? So when that happens, right, basically so in this questions, basically you need to visualize a little bit here. A right angle triangle hypotenuse is given and is rotated about the hypotenuse here. So when you rotate it like that, right, basically two cones will be formed, right? Two cones with the same base, right? The heights will be different, but the radius of the base will be the same. So basically, if you rotate about the hypotenuse, you will basically get a cone like this, right, and another cone like that. So that's when you rotate it about the hypotenuse. So now let's find out the radius, because after that we can calculate the volume. So this is a right angle triangle, right? This is 3, this is 4, and this is 5, right? The radius would be perpendicular to the hypotenuse here. Let this be h. This is the perpendicular distance from this point to here, to the hypotenuse. Right, to calculate h, we can just use the area formula, which is 1 by 2 into 3 into 4, which will be equal to half into base, which we are taking as the hypotenuse, into height. Right, so we get the height as 6 by 2.5, which is equal to 2.4. Right, now we need to find the heights, because this is the lateral area, right? This is the right circular cone, and this is the lateral area. We need to find the height of each of the cones, right? So drawing the triangle again, right, and now we know this is equal to 2.4, and this is equal to 3, and this is equal to 4, right? We can write this as x, and we can write this as 5 minus x. Now the total volume would be volume of this plus volume of this. Now writing the equation, we will get 1 by 3 pi r square, which is equal to 2.4 into h, which is equal to x. This is equal to volume 1. Right, writing the volume for the second cone will be 1 by 3 pi into r square into h, which is 5 minus x, is equal to volume 2. Pi by 2 minus x, sorry. Right, so volume 1 plus volume 2 will be 1 by 3 pi 2.4 whole square into x plus 1 by 3 pi 2.4 whole square into 5 minus 1 by 3 pi 2.4 whole square into x. So these two values are equal, so you can cancel that. So the total volume would be this. So 1 by 3 into pi into 2.4 square would be 5.76. 5.76 into 5, right? So dividing this by 3, you will get 1, 9 and 2. 192 into 5, right, into pi, right? So this will be basically 9.6 pi. Thank you.